Um, Louis, I want to thank you for kind of on short notice agreeing to jump on. I caught that article that is it really led me to read the handout that we forwarded over to everybody, and the commission has pretty much said we've got to start talking about septic again. That came up at our first meeting of the year. Consequently, we're going to be having a discussion on septic at the September meeting when we're up in the upper basin from that perspective. And I'd hope to maybe do something from the geography of the lower basin at our upcoming meeting, but that for you, Louis, conflicts with your commission meeting. So what we're going to do is you're going to give this technical committee a taste of what you're working on and what have been some of the lessons learned and what have been some of the barriers to moving things forward. We're recording this, and we may turn it into a pre-recorded presentation to the commission since you really can't be in two places at one time, but we'll talk more about that. Louis, I'm going to turn it over to you.
Yeah, so while I do this, Eldon, since I'm on my iPad, is it possible for you to bring up that PDF at page 2? Because we'll refer back to that. That's the backside that shows the problem and the solution.
You go ahead and start talking, and I'll work on that.
Okay.
Working off of 2 computers, I was sending the PDF with the other computer.
Yeah, perfect. Not a problem.
We'll get to it.
All right. So I'm Louis Lawrence, Executive Director for the Middle Peninsula PDC. I know many of you all on the call here. You all are familiar with the body of work that my commission does. We are commonly referred to as change agents. So we really do work on systemic problems and try to figure out reasonable ways of bringing solutions to problems that most communities have been unable to figure out, how to deal with. This particular one, septic, poses significant challenges to the coastal world as we're all dealing with sea level rise and flooding challenges. We knew, just because of the lower middle peninsula outside of the Gulf has the highest rate of sea level rise on the eastern seaboard, that our septic systems are always under duress. And maybe about 20 years ago, one of our AOSEs termed the Middle Peninsula the septic repair capital of the East Coast. And so we have been funding septic system repairs since 1996, for as long as I've been at the PDC. So we have constantly, decade after decade, been in this septic space, and I've watched the evolution of the technology. I've watched many of our low-lying coastal communities struggle with inadequate septic solutions. You kind of juxtapose that against the Bay program's commitment to remove phosphorus and nitrogen and sediment. So that the whole approach just does not work very effectively. And so we knew we needed to try to do something, drastically different. So we started the General Assembly trying to get some funding to begin to think a little bit more broadly about how do we deploy septic technology in rural communities in a more holistic way, with the backdrop of flooding and sea level rise always lurking. And so we started to see a couple things happen around the pandemic that really drove the need to do something different. So pre-pandemic, a single family engineered septic system to support, a regular single family home, 2 bedrooms, 4 or 5 people in the house, was running around $25,000. Post-pandemic, that exact same technology began to push 60 to 70,000. And we said, this is not sustainable. We need to do things to control prices better. We need to look at alternative approaches to septic technology. And so we had started talking with the General Assembly about some dedicated funding to try to look at this issue differently. And we also started talking with Go Virginia about different ways of building out a water management approach that could bring a lot of different solutions into the marketplace, of which septic was one. So we got a rather large Go Virginia grant at the exact same time that the General Assembly provided some money to us. And so we kind of bucketed those 2 different sources of funding into 2 different geographic areas. The Go Virginia money was spent at some public land that the Public Access Authority owns down in Gloucester, and that's the one that Eldon will be able to hopefully bring up on the screen here. And then, there you go, Eldon, go to the second page on it. And then the second bucket of money was the General Assembly money that will be used at a King and Queen facility outside of the floodplain. And so the challenge that we provided, we gave a $250,000 prize to any company anywhere in the world that could bring a septic technology to the marketplace that did two things. One was to elevate the technology above the floodplain. If you're looking at, $40, $50, $60,000 in the ground, that's probably your second largest expenditure next to buying your home, and it's not insurable unless you're using parametric insurance, which is not a well-known insurance product. And so it didn't make a whole lot of sense for us to continue to put, $50, $60, $70,000 piece of infrastructure in the ground that is one storm away from salt water frying out the computer brain and wrecking the treatment media. It just doesn't make any sense. And then the second predicate that we put into that competition was we needed to eliminate the drain field. And if we could find a solution that could eliminate the drain field and elevate the technology, now we're making critical steps forward in dealing with septic solutions in these extremely high water table areas. So we had about 6 different companies that responded. 2 or 3 of them had some innovative solutions, but one company rose to the top, and that was Triangle Environmental. So they had a technology that was actually funded by the Bill and Melinda Gates Foundation to provide wastewater solutions to countries in Africa. And once we saw how their technology worked, we knew that that could be easily adapted into first world applications. So we took a third world technology and brought it to a first world application. The company had not thought about bringing and utilizing that technology to help communities that are struggling with sea level rise and high water table issues. And so once we began to introduce to them that every house anywhere in the US that is in the floodplain suffers from this exact same common problem. And so they were able to quickly see that if they could modify their technology, that they would effectively have a solution that any community could utilize. And the third predicate that we also gave the company was that the solution could not cost more than what the current marketplace pre-pandemic was costing the homeowners. So we put some financial control constraints on it. Okay, so you can see on the image there on the left-hand side, that's the problem image. And that one is very similar to how septic tanks and drain fields are deployed in any single family home. And you will often hear people say, which is a misnomer, they will say my septic system failed. Generally, your technology didn't fail. The tank is doing what the tank is supposed to do, and the PVC pipes are doing what the PVC pipes are supposed to do. What has failed is the soil. The soils have turned to goo, and if they have turned to goo, then the effluent that leaves the PVC pipes does not either rely on that soil for the final treatment, or the treated sewage cannot be distributed correctly through the yard. And so we needed a solution that eliminated the drain field. If you can take the weakest link out of the septic technology, now you've dealt with the single biggest problem, which is the leaching field. And so the Triangle solution did just that. So what it does is, in simplified terms, it allows you to utilize and separate gray water from black water. They have technologies that will do both. And then you have to also kind of replumb your house a little bit, because you're turning your system more into a closed system. So on the image on the right, what actually happens with it, you flush your toilet, the solids and the liquids still go into the tank. The holding tank, never been a problem. That's closed. The solids stay in the tank. The liquids now go into the elevated treatment unit. And the elevated treatment unit is above the floodplain. So now you've got it out of the hazard area. It treats the liquids to the appropriate NSF standard, and it goes into a holding tank. The holding tank is in lieu of the drain field. The next time that you flush the toilet, it takes the treated water out of the holding tank and recirculates it back through the wastewater system. So now it's becoming more of a closed system. That water is treated to a high enough NSF standard. You can use it to water your garden if you want. You can use it to wash your car. So it's got other uses beyond just the wastewater treatment. But what we wanted to show was, can you in fact eliminate the drain field? So yes, that's possible, and it has been built. So the slide I sent to you all a couple photos of the very first elevated, what we think is the first elevated self-contained treatment unit system in the nation doing what this technology is doing. Now, when you see the pictures that I emailed, the very first kind of visceral reaction that most people have is, oh my God, that's so big. It's so obtrusive. It's not intended to be aesthetically pleasing at this stage. What it's intended to show is that yesterday there was nothing that looked like this. And today, now you've met a couple really significant hurdles. You've elevated the technology, so now you don't have to worry about flooding and storm surge. And you have effectively eliminated the drain field.
I assume everybody can see the 3 photos now.
Yeah, we've got the first one that's up here.
Only one? Okay.
Yeah. So this has now been permitted by the health department. When Eldon talked about some of the barriers, I will say that I am accustomed to working in really difficult and complicated regulated and permitting spaces. This journey was no exception. This was no easy task to propose something that doesn't exist anywhere in the regulatory and permitting world. And so whenever you pose something to a unit of government that doesn't currently exist, government is risk averse by its very nature. So the entire system is designed to say, no, you can't do that. So it really did take a hefty team lift to try to figure out, how do we get this through the permitting system to show that it is possible, it can be safely deployed, and then how do you bring it to market after it passes the monitoring and the scientific rigor that's necessary to be able to show that there are alternative ways of being able to do this. When they bring the unit to market, you're seeing something there that's about the size of a refrigerator. When they bring it to market, it'll probably be closer to a college dormitory refrigerator size. It's much larger so that when you open the door, you can get in there and you can show it and they can monitor it. And it's got all sorts of bells and whistles inside of it, telemetry equipment so that they can monitor on their cell phone. So it's oversized on purpose. This particular one doesn't have the holding tank because we needed for the very first one to show a really high level of fidelity that it works without risking any environmental degradation. So what's actually happening in this first pilot model is the liquids come out of the holding tank. You can see the little white pipe in the center. Those liquids go up through the treatment unit, and then they go right back down through that pipe and then return to the drain field. So it's kind of a horseshoe maneuver. And that was done so that the health department could understand that there is no risk with this first pilot program. All it's doing is siphoning out the liquids out of the tank, treating it, showing that it can meet the NSF standards, and then it returns it right back to the drain field. And so that gave the health department a much higher level of comfort of knowing, okay, we're going to step through this in a responsible way. We first want to see, can this thing in fact be elevated, and does it meet the treatment discharge standard that's needed? And then let's safely discharge it back into the drain field before we take any more steps forward with it. So that's what you are looking at here. The second bucket of money that we were able to get from the General Assembly probably 3 years ago required that funding had to be utilized outside of the floodplain. Again, this was something that the environmental community advocated for because they were very much concerned about potential impacts within the floodplain for dealing with something that is very sensitive, which is how you manage wastewater. So that commercial, that's the commercial site. So we are testing one on a single family residential loading, and then we're also testing one on a commercial facility for commercial loading, which will help with marinas and campgrounds that have and restaurants that have a much higher wastewater load will now be able to also have alternative septic technology that can be brought to the marketplace. They have not settled on the entry point price point for this, but it is going to be significantly cheaper than pre-pandemic engineered septic systems. We know that for a fact. That's what we've been told by the company. They've got monitor probably the technology for at least another year. The health department has a very prescriptive process for how you bring engineered septic systems through the regulatory permitting system that allow them to go on the list of, okay, now it's okay to buy this technology openly, and you can have companies install it. So that's where the company is right now. They are beginning to deploy several of these. They are being monitored by the health department as they go. And then as they pass all of the different tests, then they'll be able to actually bring it to marketplace with a for sale sign. So when you're talking about a transformative project of really being able to move the needle and bringing more responsible wastewater solutions to the marketplace, we have effectively done what everybody said was not possible. And we were told over and over, you cannot solve this problem. And we said, we believe that we can. And so now you're looking at the fruit of that labor. So with that, I'll be glad to answer any questions. The fact sheet that we sent out that you all have, that has been approved by Triangle Environmental, by my office, by RISE, which is one of our partners in Virginia Sea Grant. All of us have been collaboratively working on this project. So it's a lot of partners were involved with trying to figure out, how do we do this project? It's there. You all can share it. The company's welcome to talk with you all if you have questions about it. We're welcome to host a field trip if folks want to go down there and see it. We're looking at probably doing something with our congressional delegation. They have a really big interest in wanting to see this technology. That's tentatively scheduled for maybe July to get Whitman staff, Kane and Warner staff to come down. They want to take a look at the technology, see what it is, better understand it. And then we will just keep moving forward. So I'll be happy to answer any questions that you all have.
And I'll just note, Eldon had to step out for just a moment, but we do have a question from Sarah in the chat asking if there are any issues with it freezing or being affected during winter time.
Yes, so that was an interesting conversation, because being a Raleigh-based company, they are not accustomed to, even though we're only a couple hours to the north, that makes a big difference when you get into the wintertime. And so they said, yeah, it's not going to be an issue. That holding tank can go in the ground, or it can go up an elevated platform because it's sealed, so it doesn't make any difference. And you can insulate it. You can put heaters inside of it. They had heater strips inside of the refrigerator as well for this winter. But that's part of the testing, is we have to get it through, some cold cycles to make sure that, nothing freezes up. It's got to work. It has to perform. But that was the least of the problems, of the worries that we had, was what happens if it freezes. That's one of the minor ones that are on the back end of this journey that we're on right now.
Brent, do you have a question?
Yeah, thanks, Louis, for doing this. Appreciate it. I just have a question about the maintenance of it and how easily the maintenance will be able to train current companies that are in the septic market, or will it require like a new kind of business model, for lack of a better term?
Yeah, the way we've talked about it with the company and the way that they have designed it, I think most of you all are familiar with the HRSD Swift technology that they're using for injecting treated sewage. They miniaturize that same technology. So that's really what you're looking at, is taking the HRSD Swift technology and scrunching it down. And when we ask those questions about the maintenance aspect of it, they could envision it being as simple as your refrigerator at home. When the little carbon-based filter for your water dispenser, the little red light comes on, and you go in and punch the button, and out comes a sleeve, and you go to Lowe's, you could buy the same treatment unit at Lowe's. So that's one of the technologies that they are considering for how you handle maintenance, is you just go to Lowe's and buy your cartridge. And so the light comes on, you open the door, you push the button, you take it out, you put your new one in. Or maybe you have an AOSC goes down and does that themselves. So they're looking at a couple different methods for how to handle that. But the fact that their first answer to that was, oh yeah, you just go to Lowe's and get it, sent a fairly simple and clear message to us that the way that they have designed this is easy for the maintenance.
Other questions? Okay, and not to be redundant, Louis, but if you were going to be talking to local and state elected officials and saying, hey, here's some things we need to do to help make this happen? What would that be?
Well, it is going to happen because the private sector thinks there's a potential in the marketplace. So there is no need for legislative relief on this. You know, there's a lane that goes through it. What the health department recognized through this, and not only with septic, it's with all of these water management technologies. And we have brought a lot of these different companies and solutions into Virginia over the last 4 or 5 years. The bigger issue for probably the Commonwealth is, one, if they recognize that they want to be a leader in the water management space, you need to make it easier for innovation to happen in the regulatory and permitting space. So when I sat down with Lance Gregory at VDH before we even launched this, I said, Lance, I don't need perfection at this stage. What I need to know is, can you get me a permit? I don't care how circuitous of a route it takes. Do you have the ability within your permitting framework to get me a permit so that this company can flip the switch and turn this thing on? And Lance thought about it for a couple of days and came back and said, yeah, I think I can Frankenstein something together that will work, that allows my staff to sleep at night. And I said, great, that's all I need for step one. Now, the companies, as they have gone through this, have said, oh my gosh, that was such a terrible lift. And I was like, I know, nobody said it was going to be easy, but we got you to the finish line. Now, what we need to work on are ways of turning the knobs to make it easier for the next set of companies coming behind you that may want to do this. So there is a lane, but the bigger policy lift is, if the General Assembly thinks that water management solutions are something that is important to the Commonwealth, then they need to charge the different agencies with looking at how innovation relates to the regulatory processes that they use. Because we're fighting the battle at every step. Now, we can get through it, but that's not making it easy. And sometimes you want to make it easier without jeopardizing public health or environmental quality. Sometimes red tape gets in the way for red tape. And I'll use a kind of a corollary example, which I think many of the folks on here will recognize. The Chesapeake Bay Preservation Act has always been about managing water that's moving down gradient. And the RPA is the last BMP that exists before that dirty water exits into the bay. Well, sea level rise and flooding from storms is moving water uphill. The regulatory framework never contemplated water coming in the back door. So that's kind of the example of what we're talking about with the septic technologies, that these solutions were never intended to be interjected in with our regulatory permitting framework. And so that what we're illustrating to our permitting partners at DEQ, at VMRC, at VDH, is the problems and solutions of tomorrow don't fit your regulatory permitting processes of today. And so they need to be thinking that through more effectively.
Okay, so the thinking cap moment here going forward is, how do we effectuate that?
Yes.
And we need to continue that discussion.